Let's talk about the internet. I think you've heard of it. We will define the internet as a worldwide network of interconnected devices, including other networks and individual devices like weather stations and iPads and laptops and cars and refrigerators and pacemakers and regular old desktop computers. The internet is more than just the World Wide Web. The World Wide Web is actually a protocol that's transmitted across the internet, but those two things are commonly lumped together. It started as a government project to prove that remote computers could be interconnected, typically on bases, military bases, and college campuses. It had a different name. It was under the purview of ARPANET, Advanced Research Projects Agency Network, and it was text-based. It was slow, but it was a good proof of concept. If you'd like to know more about how we got where we are in today's internet, not the technical history of the ARPANET, but how we kind of got to the commercialization and the widespread use of browsers and the internet, a book called The New Thing is highly recommended by me. It's by an author that you've probably heard of, Michael Lewis, who wrote The Blind Side and Moneyball and Liar's Poker and other books that you probably read or movies that you've probably seen. So if you like to read and you have some time, I highly recommend you take a look at it. Jim Clark is a fascinating figure who has had a dramatic impact on your life, whether you know it or not. I won't tell you why. I'll leave that up to you to read the book and find out. But I guarantee that he has impacted you. So take some time to look into that. There are billions of devices online, probably. We'll never be able to count how many. The internet is just too big and too widespread and too disorganized to count all the devices. But we're not talking about just computers anymore. We're talking about specialized devices that collect data, report back to servers, communicate, control, process, and all of it uses the internet as a way of transmitting that data back and forth. We mentioned protocol earlier. A protocol is an agreed upon standard that two or more computers will use to exchange information. The information may be an eBay auction or an email address or an email or the information from a weather station or the status of your car or a connection for your video game. All these different exchanges of information require protocols. I've listed some common protocols here. We're not going to study them in any great detail, but if you go on the internet using your browser, you're probably using HTTPS, Hypertext Transfer Protocol, secure. The S is secure. The early days of the World Wide Web used HTTP. That is still popular, but it's being eclipsed by HTTPS because it's more secure. Many protocols fly across the internet, so be able to differentiate between the World Wide Web, www, using the HTTP protocol, and the internet, which is simply the connections of the entire interconnected world of computers across the whole globe. Here is a protocol model that you will see for the remainder of your career. You will see it in many classes that you take. And you will use it to understand how the internet works, how security works, how data is transmitted and processed. We typically refer to it as the OSI model. And again, it's not something we're going to go into in any great detail, but at the bottom of the model is the transmission media. And then at the top of the model is a program that you're using on your computer. And information flows up from the bottom and is processed by different protocols until it finally reaches your video game or your email client or whatever program you're using to communicate. Every computer on the internet needs to be uniquely identified so information can find it. And we generally use an IP address to do that. IP stands for Internet Protocol. Now, sometimes those addresses are shared to some extent, but we generally, as a broad description, say that every computer has a unique IP address at any given time. If you turn your machine off, or even if you let it sit for a while, you may be issued a different IP address the next time you try to use it or the next time you turn it on. But you can generally rest assured that whatever you're doing is tied to a unique IP address as you are doing it. To get a little more specific, you have an IP address on the local network. And again, I'm talking about a situation that most people fall into. You're at home, you've got a router that was provided for you by your ISP. You may have another router connected to that router that you bought from Best Buy. That local network in your house has an IP assigned to your computer, and then the internet has assigned an IP address to your router, so that we have something called a WAN IP that identifies essentially your entire network to the internet. And then on the other side of the router, on your home side of that router, all the devices have IP addresses unique to that side of the router, that home network that they're on. Another way computers are uniquely identified is by a MAC address. MAC stands for Media Access Controller. Now, when you buy a device that's going to go on your network, whether it's your phone or a printer or your computer, your iPad, it comes with an Ethernet card or some other type of network card, a wireless card. And on that card is a semi-permanent MAC address that tells a little bit about who made that card and perhaps when it was made. Now, that address can be spoofed. Okay, we can easily install software on a device to make that device look like it has another media access controller address. So I don't want to get into an argument over whether or not this is permanent, but for most people who simply use their computer to accomplish a task, they are using the burned in or semi-permanent MAC address on that, assigned to that card, which links to that computer. The internet needs to do two general things to work. One is route information across all those wires around the world, and the other is to make sure that information arrives correctly and gets reassembled correctly along those wires. So we talk a lot about the concept of routing. If you think about the phone system, you pick up the phone and you dial a number and you really don't know how you're connected to your party at the other end. The same thing applies with routing on the internet. There are many different ways that a call or a packet of information can be routed across many different paths. and that is a science in itself. So configuring routers, securing routers, making them run efficiently is a profession in the IT field. The IP address assigned to the devices on your home network is going to be assigned by some router. And again, you may have two routers at home. You may have the one given to you by your ISP, Cincinnati Bell, Spectrum, AT&T, whatever. And then you may have purchased one. Either way, one of those two routers is assigning IP addresses on the LAN side, on the home side, to all the devices. And that includes any cell phones that want to use your Wi-Fi or your Ethernet connection. That includes any printers that jumped on your network. That includes the guy down the street who's stealing your Wi-Fi. Any devices, your smart TV, all of them have IP addresses that have been assigned to them by the router. And again, I'm still talking in generalities here. There's always a little caveat now and then, but this is generally how it works. Your router manages the IP addresses on the local side of your network, the LAN side, and connects your LAN to the internet, the WAN side, and performs some security features by implementing a firewall and other things. So it's a busy little guy. You can see from the diagram that you may have mobile devices and laptops and phones and printers, all using the router to connect to the local area network and then also go out to the internet. Now, to be clear, when we say router, 99.9% of the time in a home networking environment, we're talking about really two things: a router and a switch. The router connects two networks together, the LAN and the WAN. The switch provides Ethernet ports on that network. Now, you could buy those separately. It's extremely unlikely that you would ever want to do that. If you go to Best Buy and you stand in line, you may find, or you will find without question, routers and switches together in one unit. So most people would never have an occasion to buy a router separately from a switch in a home network environment. If you'd like to see your LAN IP address, and I hope you do, in a Windows environment, it's fairly easy to do. You can bring up a command prompt, and then you can type ipconfig. This is not a dangerous thing to do. It's not going to violate us any security protocols. It's not going to break anything. So you can do this with impunity. And looking at mine, I'm on a laptop here, but I'm connected via an Ethernet cable to my router/switch. And my IP address is 192.168.56.1. So the router at my house has assigned this laptop computer that IP address. Now you'll notice if you look down a little bit farther on my screen that I have a wireless LAN adapter that's disconnected, meaning that I don't have a wireless connection to anything. And the reason I'm using the Ethernet port on my laptop is because it's faster than a wireless connection. So since I'm sitting in the same room with a router, it's more convenient and more efficient to plug it in directly to the router with an Ethernet cable. I could unplug the Ethernet cable and turn on the wireless adapter, and I would still get an IP address from the router. It might be the same one, it might not, and still do my work. And here's another example. So in this example, the Ethernet adapter was assigned the IP address 192.168.1.18. We could spend a semester discussing IP addresses and routing with no problem. But for now, your takeaway should be the computer has a unique number called an IP address that identifies it on your local area network. It has a unique IP address called a WAN IP, Wide Area Network IP, which identifies your LAN on the internet. Now, the WAN IP is assigned to you by your ISP. You don't have any control over that at all. You may pay extra money to get a static WAN IP because you want to host a website or a game server or database server or something so people can find you. But you probably are not doing that. Now, this WAN IP is how the internet recognizes you at this moment in time. In 5 minutes or tomorrow, you may have a different WAN IP. Your ISP may be reassigning you a WAN IP address at any time, unless, as I said, you're paying for a static WAN IP address. It's not a bad thing. If you go to some sites and you buy something, you may see a warning that says we have logged your IP address and this is what it is and we know who you are. Well, they really don't know who you are. They know your WAN IP. The WAN IP can be tracked back to the ISP. To track it all the way back to you requires a lot more effort and is something that most ISPs are not going to do. Now, that doesn't mean they won't. But just because a website has your WAN IP does not mean they know who you are. The FBI, probably with the stroke of a pen, could trace that WAN IP back to you through the ISP using some legal justification, but the average website that captures your WAN IP cannot go much farther than that. You also may be sharing that WAN IP again. The ISP has control over that, you don't. Sometimes it's interesting to know what your WAN IP is just as an academic exercise. And there are sites you can go to that will tell you what you look like at that moment in time on the internet. Here is my current WAN IP. I loaded up whatismyip.com in my browser. It tells me that my current public WAN IP is 72.49.217.193. That tells nobody anything. It can be linked back to my ISP, which as you can see is Fuse. Fuse owns that IP address in a block of IPs that they pay for, but that doesn't point to me directly. If I broke the law, if I did something that required me to be traced, conceivably my ISP could find out, could give up the information that I was using that IP address at this moment in time, but that information is not readily or easily or in any way available by just the websites that you log on to. So if you see that someone has logged your public IP or your WAN IP, I wouldn't worry too much about it. It's just a way of trying to scare you. If you want to know who owns that IP address, you can use another website to learn that information. I use dnsstuff.com and I plug in an IP and it tells me who has registered that IP or who owns the right to use that IP across the internet. Again, it's public information for the most part, but it does not point directly back to you. It only points to your ISP. This is an interesting little exercise because if you'll notice, you may have used on your phone, you may have received perhaps a Google ad from another part of the United States. I have a cell phone provider who gives me a WAN IP on my phone that is registered somewhere in Pennsylvania because I get ads for car dealerships and barber shops and all kinds of services on my phone that are local to Pennsylvania, particularly Philadelphia, which is weird. But since I understand that my WAN IP is registered to a company that is in that region of the country, and the only thing that Google can tell about me from the IP is where that IP address is registered, that's the best it can do. So it's serving me ads that really have no relevance to me at all because I don't live there. But by virtue of that WAN IP being registered in that part of the country, that's where it decides to serve the ads. So the next time you see an ad from Colorado or California or Alaska, maybe it's because your WAN IP is telling them that's not where you are, but a good guess of where you might be. That also happens a lot in hotels. If you use the wireless system in a hotel, that wireless network is being provided by a third party. The hotel isn't doing that typically. And that third party is probably in another state. They own a WAN IP. They've registered a WAN IP to another physical address in another state, and that's why you get weird ads when you use that wireless network. So ISP is Internet Service Provider. At your house, you're paying them money. Related to the cell phone, you're paying your cell phone carrier to also be an ISP. So you probably have in your life at least 2 ISPs that you're paying money to. And they will lease you or loan you or assign you a WAN IP, and that gets you onto the internet pretty much. You can't change that WAN IP. You can't control it unless, as I said earlier, you're paying for a static IP that's not going to change. Some IP issues that we've run into. As we saw, it's 4 numbers separated by dots. They're numbers that we see in base 10, but they actually originate in base 16 or base 2, so they look kind of weird. But there is a finite number of those addresses. And without doing the math for you, I will just tell you it's 2 to the 32nd or over 4 billion unique numbers. Now, there's a lot of those that we just can't use because they have reserved uses. But even if we had full-blown access to all 2 to the 32nd, all 4,294,967,296 different IPs, we would still be way, way, way short of what we need because there are just too many devices wanting to get on the internet, and that's not enough unique identifiers anymore. So what we're doing is slowly transitioning away from IPv4 and introducing IPv6. It's been a long process. IPv6 is installed on devices, but you still see IPv4 information popping up. Now this little guy has 2 to the 128th different unique IP addresses, or in base 10 it's 3 by 10 to the 38th, which is a lot. And I will also tell you that I have no doubt that when the internet was first created, conceived, and designed, somebody said that 2 to the 32nd was a lot, and that was more than we would ever need. I'm sure that they were confident that 4 billion IP addresses would be more than enough. Well, guess what? It's not. So I'm not going to tell you that 3 by 10 to the 38th IP addresses is enough. It looks like enough. It's a big number, but who knows what could happen in the future. So we won't say that we are in the grasp of a solution that is permanent, but it's a pretty safe bet that we're going to be okay for a while. Okay, IP addresses are terrific, but they're numbers and nobody wants to memorize numbers. So we have a system to map IP addresses to what we call domain names. And when you open your browser and type in Amazon.com, your computer, in conjunction with other computers, resolves that to an IP address. And if I go back to my command prompt, I can run a command called ping, and that will do one thing, but another thing that it does as a side benefit is resolve Amazon.com into an IP address, and you can see how that works. So Amazon is 176.32.98.166, and that is the number that is used across the internet to uniquely identify Amazon.com. That works, but it's problematic for humans to remember that. So instead of having to remember 176.32.98.166, we just remember Amazon.com, and then there's a lot of magic going on in the background that connects those two things together. And watch this. This might blow your mind. Memorize that number, 176.32.98.166. 176.32.98.166. Did I get that right? 176.38.98.166. I can't even say it now. 176.32.98.166. Enter. Well, it wants to go somewhere, and my security software is telling me that I probably don't want to do this. So I am going to pause the video and double check exactly what's going on here, and then I will get back to you. All right. We have attempted to use an IP address instead of a domain name in our browser. And instead of popping into Amazon.com as we typically would, we have a certificate issue. A certificate is a way of authenticating that this site is who it says it is. And if you read all this text, you can see that the certificate certifies a whole bunch of domain names, but not enough to make the browser happy. I would not recommend that you do this on your own. I am 99.99% confident that I'm okay to continue on here. I don't think there's a I don't think anyone's trying to attack me, so I'm going to accept the risk and continue. Man, I got an X. I got nothing. All right, this didn't quite work out, because it sent me to what looks like a completely empty web page. So I'm going to try this again. I'm going to start over because I would like this to work. And I'm going to ping Google. And Google is 64.233.177.100. Double check that. 64.233.177.100. Let's see what that does. That took me to Google. That's what I expected Amazon to do. So I was able to demonstrate what I wanted you to see, is that I can use an IP address in place of a domain name. But I'm sure you realize that trying to memorize 64.233.177.100 is problematic. It's much easier to remember google.com. And I don't have an explanation for why the certificate issue popped up when I tried to do that with Amazon. but I think that's an outlier. The resolution of domain names and IP addresses is another function of, and I'm generalizing, but your router in conjunction with your computer and other routers across the internet. That's all I want to say about that right now. There is a service called DNS, and that's what maps up domain names and IP addresses, and we won't talk about that right now. The top level domains, the last few characters after that dot, .com, .edu, .org. At this point, you should have heard of those. Everybody's visited a .edu site or a .com site, a .org site. There was a very limited number of those in the early days of the internet. That number has ballooned dramatically. So you can find top-level domains, TLDs, that relate to specific categories of websites rather than just general commercial or general edu. So it's easier these days to find a domain name that fits your website because there are so many more TLDs than there used to be. An interesting story about TLDs. A few years back, there was a company called Clear Channel, which is now iHeartRadio, which kind of originated in Cincinnati, believe it or not. And they had a plan to corner the market on the .cc TLD. Of course, Clear Channel, CC, kind of matched up to .cc, and they thought that was a great marketing tool. And on all of their radio outlets, they were selling CC domain name registration services. They wanted you to move your website to .cc. And this was before the explosion of TLDs. But it was the country code for this set of islands, the Cocos Islands, not Turks and Caicos. And they went to that entity, I guess it's a government or country, and Clear Channel said, we want to buy the rights to market the .cc TLD. So all of the Clear Channel radio stations went from .com to .cc, WEBN.cc, WLW.cc, and so on. And guess what? It didn't work out very well. It just didn't catch on. And they've all since shifted back to .coms, which are easier to remember. But it was an interesting marketing effort at the time because people weren't familiar at that time generally with TLDs, and they didn't know what CC was. And I'm sure a lot of people were just unable to remember it. If you wanted the WLW radio website, you probably didn't think that it was a .cc top-level domain name. So that did not go well for Clear Channel, and they have since abandoned that effort. Today, I think every country has its own TLD or country code, plus all the other ones that are specific to different website categories. But for the most part, as you probably have realized, most people tend to put things in the .com TLD because they're easier to remember. Okay, we talked about protocols earlier. Here's a complete web address, http://www.uc.edu. HTTP is your protocol, hypertext transfer protocol. Across the internet then, that protocol is used to send websites to your browser and to communicate back to that website from your browser. You probably laid awake at night wondering who manages all this stuff. Who decides what the TLDs are? Who decides who gets to be WLW.com? Well, there is an organization that assigns internet names and numbers, and they worry about those things so we don't have to. It's a bunch of men in suits, apparently, and they decide what TLDs will be created, how the TLDs will be sold, how much it's going to cost, and all the administrative details so that we can go to google.com and search for things and go to amazon.com and buy things. Without these people, there would be more of a wild, wild west atmosphere on the internet, and we'd have an even more difficult time finding web pages. Another interesting thing that goes on with domain names is that they are bought and sold. One of the big ones was business.com in 1999. It's been a while. Somebody paid $7.5 million to somebody else for the right to use business.com because they thought when somebody wanted to do business, they would type in business.com into their browser blindly without thinking, and they would be sent directly to whatever website was there. That seemed at the time in 1999 to be worth $7.5 million. I don't know how that worked out, but I do know that these days domain names are bought and sold and traded, and there are markets to do that. Here's one example. Whoever owns fastcars.com thinks that you should be willing to pay them $250,000 for that domain. Whoever owns bestdeals.com thinks that their domain is worth $1 million. I don't know if it's true. I don't know how often these things actually sell, but it is a speculative industry that people probably make some money at. I have tried it myself. I have registered domain names in a speculative fashion, hoping they would someday become valuable. I have never been successful. Now, domains are cheap to register, so it didn't cost me a lot of money, but no one has ever come knocking on my door offering to buy any of my domains. The internet, aside from www resources, also does plenty of other things involving the transmission and communication of information. Certainly, when we're working from home, we need storage capabilities. We need to communicate. Microsoft Teams has become a huge tool these days for people working at home. There are virtual computers available to us online at very reasonable prices, provided by Amazon, Google, other companies. And of course, we can share files using Google Docs. So the World Wide Web isn't all we do with the internet. Much more other information flies across those wires. Here's a question you should ask yourself. You should say, self, do I still need a traditional computer? After all I know about the internet, I know that I can log into a virtual computer in the cloud. I can store my files in the cloud. I can play games in the cloud. Do I need 32 gigabytes of RAM and a 4 terabyte hard drive and a 4 gigahertz CPU on my desktop anymore? Something to think about. I will tell you that we are moving in the direction of virtualized computing, and we are moving in the direction of virtualized computing in the cloud. So the sale of desktop computers has dropped dramatically because businesses and schools are virtualizing those resources. In other words, what used to be a physical computer on a desk is now a virtual computer modeled in software in the cloud somewhere. It's much cheaper and much more reliable to do it that way. The benefits to having that desktop computer, of course, you don't need to be on the internet to do some of your computing. But these days, how many of us are not on the internet, and how many of us could survive without the internet? The disadvantages, well, somebody else might look at your data because it is in the cloud. Now, I know that the cloud providers will tell you otherwise, but who knows? Your bandwidth is an issue. Do you have a fast enough internet connection to do cloud computing? And are you skilled enough to set up your own cloud computer and use it like you would the computer on your desk? So how much of your extra effort and resources and time would be consumed by simply learning how to cloud compute when you could just desktop compute as you normally have? But keep an eye out for virtual computing. It's a career path, and it is the wave of the future. Thank you.